ICE, high speed on rails. Top speed, 330 kilometers per hour.
The first time I drove over 200 kilometers per hour in the driver's cab, it was pure adrenaline.
The training on the simulator, extremely tough.
Malfunction. Malfunction.
Oh, damn.
The fight against the ravages of time. Beauty treatment in the interior.
They're washable. There's anti-graffiti protection on them.
New high-speed lines, gigantic construction sites, tight deadlines.
The work is to be completed in 4 weeks, otherwise the entire construction project is jeopardized.
And the next generation. Brake test on the ICE4.
Emergency brake.
The ICE, a success story with setbacks. The ICE depot at Munich Central Station. This ICE1 is heading off to Hamburg-Altona today. But first, it has to be transferred to Munich Central Station. That's the job of train driver Kerstin Schwendner. Before departing, the 23-year-old checks the systems, particularly the brakes.
We check whether the brakes apply and release. Because we have several brake systems, one electric and one pneumatic. We have to check both. I actuate the pneumatic hand control, and on this display I can see each car, the power units are here, we are sitting here, that all of the brakes are applied.
And the electrical actuation of the brakes functions perfectly as well. The signal switches to green. The train driver can leave the hall.
With the attention whistle, I first check whether the whistle works and also warn the depot staff because, as you can see, it's pretty difficult to see people here. That's also why I have to drive out very slowly, because it's just very dangerous. Because the train doesn't immediately stop in 2 seconds.
This transfer movement is regarded as a shunting movement. This means that the maximum permitted speed is 25 kilometers per hour. Nevertheless, the train driver has to be extremely careful when entering the railway station.
The difficulty in the entrance lane to the buffer stop is that I have to watch my speed, I have to brake, but I also have to watch out for passengers. We are fortunate today that they are not standing too close to the edge, because often when a train arrives at the other platform, people walk on the far right and don't see me coming with the train. And the suction effect is already there, even at 25 kilometers per hour.
While the onboard restaurant is quickly being stocked and empties unloaded on the platform, Kerstin Schwendner hands the ICE over to train driver Lutz Jäckel, who will drive the train to Kassel.
With our preset speed selector, that's for automatic motor and brake control, I set the permitted speed.
The preset speed selector basically functions like a cruise control system in a car. While departing from Munich railway station, the 24-year-old has to stick to a top speed of 40 kilometers per hour. Then, Lutz Jäckel can accelerate.
The signal in front here is now showing expect stop. So in 1 kilometer, we have a red signal. We have to stop ahead of it. We also have to acknowledge this signal. If we don't, the automatic brake is applied. Okay, the signal ahead has switched to clear, so we can accelerate again.
But only for a short while, because the ICE is approaching Pasing railway station and not on the usual track.
Now the traffic controller is calling us. 882, good morning.
Lutz Jäckel is asked to reduce his speed again, quite considerably.
Right, okay. Going past the platform. Thanks, ciao. He's now told me that we'll be driving along the platform. That's why we have to do 60 kilometers per hour. Normally, we'd have shot through Pasing at 130 kilometers per hour.
The train driver can accelerate again. At speeds over 160 kilometers per hour, he no longer runs visually.
Now I have the signals in the driver's cab. The signals on the open line no longer apply to us. They can be set to red. As long as the signals here in the driver's cab allow us to run, we'll run. Now we've got a clear line for 9,900 meters, around 10 kilometers, and we can do 200 kilometers per hour.
In the traction unit, Lutz Jäckel is the boss, but further to the rear in the cars, Caroline Regel says what goes.
Good morning, ladies and gentlemen. Welcome on board the Deutsche Bahn ICE to Hamburg-Altona. We hope you have a pleasant journey. Just to inform you about our catering service on board, today we can recommend our delicious scrambled egg breakfast with freshly prepared coffee. Why not pay our onboard restaurant or onboard bistro a visit? We look forward to seeing you.
Wir freuen uns auf Ihren Besuch.
As the train manager, Caroline Regel is responsible for communicating with the passengers and the traffic control center. When it comes to whether the train is punctual and the passengers can reach their connecting trains, for example. The 29-year-old is also responsible for safety on board, for ticket inspection, and for the technology in the passenger area.
During our ticket inspections, we also take a look in the restrooms to see whether the flushing mechanisms functions, whether the wash basin water functions, and we also check whether there are any fare evaders in the restroom, because that's usually their favorite hiding place.
She also has to make sure that the onboard restaurant is resupplied.
Cavo, I have an order for you.
Great. For which railway station?
Preferably Castle if you can manage it.
Right, I'll see to that.
All right, thanks.
She easily takes care of the order using her cell phone. The ICE is now traveling at around 230 kilometers per hour, routine for Lutz Jäckel.
The first time I drove over 200 kilometers per hour in the driver's cab, it was pure adrenaline, because there's simply no comparison with a car. If I wanted to brake now, I'd need around 2 kilometers. Now, speeds of up to 250 kilometers per hour have become completely normal for me. You simply get used to it. Over that, up to 300 kilometers per hour, the adrenaline comes into play again, because that's not an everyday occurrence.
The ICE, with a top speed of 330 kilometers per hour, the flagship train of Deutsche Bahn. Its story began in 1985 with the Intercity experiment. It was succeeded by the ICE-1. 5 of these trains arrived at the new Kassel-Wilhelmshöhe railway station from various directions in the spring of 1991. The era of high-speed rail travel had begun in Germany.
I would like to wish you, your team, and all German railway workers safe travels at all times. And I'll now switch the red button to green.
The ICE was the pride of the nation. Finally, the country had pulled level with the TGV operated by its neighbor, France. In the coming years, it was followed by the ICE2 and ICE3 with various technical specifications, such as the ICET, a train with tilting technology, which enabled it to run at relatively high speeds even on winding routes. Meanwhile, the first ICEs were showing their age. Over 1 billion passengers and the ravages of time had left their marks. The ICE depot at Munich Central Station. The 400-meter-long hall can accommodate up to 12 trains. What is called a reset program is currently underway here for the ICE 1, 2, and 3. This means that the trains, some of which have already been in operation for 25 years, are given a visual and technical facelift. On the ground, this campaign is being managed by Christina Dordich, among others. She is a vehicle technology engineer.
During the reset, we have the opportunity to take our ICE vehicles out of operation for 1 to 4 days, so that we have time to repair all comfort defects. For example, these worn headrests simply don't look very nice any longer, and we want to refurbish them.
The technicians check each individual seat: backrest, head section, armrest, seat surface. Whatever is worn out or excessively scuffed is replaced with new elements. However, the reset program also includes minor optical corrections, such as the floor strips in the first-class section. The restrooms in the ICE3 have recently proved to be a real nuisance. Not only do they no longer look very appealing, some of them are also technically defective.
After many years of operation, the old washstand flaps were badly damaged and some of them no longer functioned correctly. They could no longer be closed, the toilet paper no longer stayed in them properly. That was simply no longer acceptable for our customers.
So out they go. The restrooms are to become more appealing thanks to films, which employees of a specialist company are sticking on the walls. Fake mosaic tiles with a flower design. But the film also has a very practical benefit.
They're washable, there's an anti-graffiti protection on them, and they can be cleaned very quickly. There's a laminate on them, a clear laminate, and that protects the design too. So they're protected from scratching and they're washable. They're just very good.
So, anyone who wants to immortalize themselves here with pens or spray cans can think again.
The film has to be hidden a little so that it can't be peeled off right away. That's why it's installed behind the mirror and the fittings.
Now, all that remains is to cut off the excess film and the restroom is finished, with new washstand flaps and a disinfectant dispenser. The difference compared to before is like night and day. Besides the reset work, major repairs are also carried out in the ICE depot in Munich. Metal worker Alois Ellmauer and his colleagues have a complicated job ahead of them on the ICE with tilting technology.
The spring-loaded brake on this wheel set is defective and we have to exchange it. To do this, we have to remove the entire wheel set so that we can get to the spring-loaded brake to replace it.
The spring-loaded brake additionally has a parking function, like the handbrake on a car. Alois Ellmauer now moves a changer, a type of hydraulic lifting platform beneath the wheel set. It's used to raise the wheel set until it is no longer touching the rails. Once all the bolts and connections have been released, Alois Ellmauer removes what is called the track bridge, which would otherwise be in the way during removal. Supports are then positioned beneath the bogie and the wheel set is lowered. So that the 1,600 kilo part is unable to roll away, the metal workers have to secure it with wedges. Alois Ellmauer now raises the wheel set and moves it out from beneath the train. His colleagues can now get to the defective spring-loaded brake and dismantle it.
Once the old spring-loaded brake has been removed, we install the new one. Once it's fitted, we install the brake pads again. Then we reinstall our driven wheel set. And when everything's finished, the train undergoes a brake test, and then it can go back out on the track.
The ICE1 that train driver Lutz Jäckel is driving from Munich to Kassel today is now passing through several tunnels.
As regards visibility in the tunnel, it has to be said that the train driver sees little to nothing. So the main beam headlamps on the older generation vehicles are by no means the best. And it has to be said that if there are people on the tracks, for example, you can't see them at all. On the more modern ICEs, the entire tunnel is lit up.
Ladies and gentlemen, we're now arriving at Würzburg Central Station. Please exit the train on the left.
Train manager Caroline Regel has to be extra attentive in the railway stations, especially just before the train sets off again.
Now I have to make sure that everybody has got on and off, that's completed. And now we're all set to depart. So, off we go.
Caroline Regel wants to check the tickets of the passengers who've just boarded the train, but she's unable to do so for the moment.
Right, the buggy shouldn't be here, because these are entrance and exit doors. So there are also escape routes, and they have to remain clear. Now we have to find out who the buggy belongs to, and then we'll have to make sure that it's removed.
The owner of the buggy is quickly determined, but the problem remains.
So the lady doesn't know how to fold the buggy together. I'll go and get my colleague to help, and then we'll see whether we can do it. This is an announcement. Could the colleague from the onboard bistro please come to car 5?
Her colleague arrives 2 minutes later.
What's the matter?
Right, we have to take a look and see whether we can fold the buggy up. The lady doesn't know how it works, and I thought we might be able to do it together.
If nobody else can do it, we'll manage it somehow.
With just 2 moves, the employee collapses the buggy.
Wonderful. Let's put it in that compartment. Then it's out of the way. There's still some room in here.
While Caroline Riegel now has to inspect the tickets, train driver Lutz Jekyll doesn't have a lot to do, at least at first glance.
In railway circles, we're often referred to as straight-ahead drivers because we don't have to steer. But we have to pay attention to lots of other things. For example, braking, whether there are hazards on the track, and we also have to keep the timetable in mind.
And that now says, slow down.
So we're now braking for Fulda railway station.
Fulda Central Station, a Model Series 411 ICE, an ICET with tilting technology, which can also run at high speeds even on winding routes, is just arriving from the opposite direction from Berlin. 50-year-old Rico Chernetsky is sat in the driver's cab along with a trainer. He works in Berlin and transfers trains from the train allocation depot to the railway stations. He is not yet allowed to drive the ICE with tilting technology, but he wants to obtain his license for it now in the Deutsche Bahn training center in Fulda. Among other methods, future ICE train drivers are trained here in the simulator. Friedbert Kraus, one of the instructors, is getting the simulator ready to operate.
The main component of the simulator is the AFB, the automatic motor and brake control. The train driver can use it to set the maximum speed. The traction adjuster, pretty much like the gas pedal in a car. The driver's brake valve, i.e. the brake. The ebula, our timetable, our technical display for malfunctions, and down here is our DSD, the driver's safety device. The train driver has to activate this every 30 seconds. It's used to determine whether the train driver is still okay health-wise, and if he doesn't operate it, the train stops after 30 seconds. Hello, Rico.
Good morning, Friedbert.
How are you?
Good.
Rico Chernetsky now has 4 days to practice operating the ICE in the simulator. Then he has to take the test.
Then make your way upstairs, please.
Okay, I'll be in contact.
Right, okay.
It's stressful, because you can only simulate and experience all the malfunctions and contingencies that don't arise during a normal operation on a simulator run like this. Often it's the case that in normal vehicle operation everything is fine, I'd say in around 90% of the cases, but here on the simulator you can encounter everything that can go wrong in theory. On the vehicle, with the vehicle.
And quite a lot is going to go wrong today.
So, Rico, you can take over your vehicle, okay? Your train number is 9300, and we're traveling from Fulda towards Würzburg.
Okay, 9300?
That's correct.
The simulator run takes place in real time, a 32-minute timetable.
And off we go. Here in Fulda, we can drive out of the railway station at 100 and then 140 kilometers per hour. My guidance text says no malfunction. That's very good.
But that doesn't remain the case.
So the display is now showing me how fast I can go, 200.
Up to 160 kilometers per hour, the maximum braking distance is 1 kilometer. The signaling systems are positioned accordingly. If the train is going faster than 160, the train driver would no longer be able to stop in time when he sees a red signal. This is remedied by the so-called continuous automatic train running control system, which shows the train driver a red signal before he can see it himself. If the train driver fails to react to it, the system intervenes automatically.
So now we're driving with the continuous automatic train running control system, the LZB. I'll now load the traction motor overtemperature malfunction. One of the drive systems will then stop working for a certain time.
Malfunction. Malfunction. Malfunction.
And a malfunction has just occurred. Traction motor over temperature. Measures, no measures required. Continue travel with reduced drive power in this traction unit. That means we're driving with 70% power.
Right, Rico, if that's present for a long time, you can report it to your traffic control center.
Yeah, I was just thinking about that. Can't do any harm. Yes, hello, hi, this is the 9300.
The right response on the whole, apart from the uncertainty as to whether the incident has to be reported to the traffic control center.
So the next malfunction I'm going to load won't be shown on his display. Instead, he has to react by himself.
Malfunction.
Oh, damn.
Malfunction.
Rico Chernetsky must have made some kind of mistake. Back in the ICE-1 on the journey from Munich to Hamburg, train driver Lutz Jekyll is familiar with situations in which you're simply perplexed or even powerless.
The worst situation I ever had was children playing in the track area. They were playing with the ballast. I quickly activated the emergency brake, but I have to admit, it wouldn't have been enough if they hadn't moved away from the track, if they hadn't registered my attention whistle. You really start to sweat then. It makes you really nervous, because you have no control over it. Basically, all you can do is watch. You can only slam the brakes on and hope that the vehicle comes to a stop in time.
It's almost 12 noon. The onboard restaurant is now getting ready for lunchtime. The 3 railway employees in the kitchen really have their hands full. During peak times, up to 80 meals per hour have to be served.
So here's the order for 21. Pork cheeks with cabbage and salad with chicken breast and balsamic dressing.
Okay, I'll see to that. Here are the 3 components for the braised pork cheeks, pointed cabbage, potato patties, and the pork cheeks. This is convenience food. It's all pre-cooked. Now it's just heated up. I put them into the steamer here. They have to stay there for 15 minutes. Then they're nice and hot. So what else was there? Chicken breast? The advantage of this system catering is that it's very quick and the quality is the same on each train. We can guarantee the same product with the same quality on every train. And it's presented the same way. So each guest immediately recognizes it. Right. Before I can present my food, I'll just do the dishes for first class. Potato soup. Right. That still needs a bit longer. The menu in first class is similar to that in the restaurant. It's also the same in terms of prices.
Meanwhile, the cabbage, potato patties, and pork cheeks are ready.
Sometimes it's a bit problematic when we go through switches and the train wobbles. It's difficult to present everything well so that it looks really nice. Of course, some of the food occasionally spills over the edge of the plate and can no longer be used. That's completely normal. Then you simply have to dress it up a bit. Do something new. That's totally normal. You stand with your legs pretty far apart and try to balance things out a bit, you see. I'll put the salad on the plate now. There are 2 people sitting at the table, and we want to make sure that the food is always served at the same time. After all, they want to eat together. Okay, that's that. Now it can be served.
20 minutes after ordering, the 2 guests' food arrives. At the same time, as it should.
1 salad with chicken breast. And 1 braised pork cheeks with cabbage.
Thank you.
Enjoy your meal.
Together with a quarter of a liter of red wine, that comes to €32.30. Back in the driver's cab in the ICE.
So we're now coming up to Kassel railway station. We don't have permission to enter yet. In 2 kilometers, we have an expect stop. That's exactly 1 kilometer ahead of the platform.
Lutz Jekyll applies the brakes. So that the train doesn't come to a complete stop, he has deactivated the automatic brake control system.
Now we're allowed to enter at a target speed of 100 kilometers per hour.
For Lutz Jekyll, the journey comes to an end in Kassel railway station. Another train driver will cover the remaining stretch to Hamburg-Altona.
Right, my colleague is already waiting, so we'll get everything ready for the handover.
The handover also includes a verbal report about technical problems, if any have occurred during the journey.
No problems with the train. Have a good trip.
Lutz Jekyll now has a 1-hour break. Then he will drive another ICE back to Munich. The Deutsche Bahn training center in Fulda. Rico Chernetsky is still practicing in the simulator. He wants to get his license for the ICET, the ICE with tilting technology. He coped well with the first malfunction that trainer Friedbert Kraus loaded into the simulator for him. Now, however, the training program will become more demanding. The instructor sets an emergency stopping point on the track using the continuous automatic train running control system, the LZB.
An LZB emergency stop might mean that a train is still 5 or 6 kilometers away and the driver sees something lying on the opposite track. And then they can set an LZB emergency stop.
Malfunction. Malfunction.
Oh, damn.
Malfunction.
Rico Chernetsky has not recognized the emergency stop as such. His train is automatically braked by the system. The simulator tilts forwards. The train comes to a standstill in a tunnel. This time, the 50-year-old immediately calls the imaginary traffic controller on the radio.
This is the 9300. The train's just been braked by the LZB.
What are your display readings?
Stop and 100,000 hertz flashing.
The computer says you ran through an LZB emergency stop. Is that correct?
Yeah?
Okay, listen. I'll find out what's going on. I'll get back to you right away, okay?
Okay. The most difficult thing is to recognize the situation that's unfolding. I mean, when the system says malfunction, to recognize the malfunction, process it, and not forget anything, as well as the operational procedure, driving, continuing to monitor the route. And this multitasking is exactly what's needed in the simulator.
Yes, probably something unknown occurred. You'll receive a command from me that you can proceed, okay?
Right, thanks. See you.
In theory, the journey can now continue. In theory.
Malfunction. Malfunction.
Why won't the brakes release now?
First, perplexity, then recognition. The speed limiter is still set to 0.
Now. Well, when you're doing all this for the first time.
Finally, the train starts moving again. After traveling for a further 3 minutes, it arrives at the destination, Würzburg.
So, we made it.
The tiring exercise in the simulator is followed by the debriefing.
So, Rico, we ran through the LZB emergency stop.
Yeah.
What were you thinking?
Well, first I was a bit annoyed because I didn't recognize right away that it was an LZB emergency stop, because I haven't experienced it for a long time. In real life, something like that doesn't happen often.
You'll pick up all of these little things again.
Yeah, I'll get used to it.
And then everything will be fine.
Yeah, a week will be enough.
Rico Chernetsky is confident that he will pass the test for the ICET with tilting technology. The ICE, a success story. Each year, 250 trains transport around 80 million passengers. However, the history of the ICE has also been marked by several setbacks. The most bitter of these was the train crash in Eschede. On June 3, 1998, the ICE Wilhelm Conrad Röntgen derailed and slammed into the center pillar of an overpass. 101 people lost their lives. 88 were severely injured. The nation was in mourning. The cause of the accident? The breakage of a wheel. The Deutsche Bahn drew the necessary consequences from Eschede. Rubber-sprung rail wheels were no longer fitted, and the maintenance intervals were changed. Wheels and shafts are no longer inspected periodically, but according to mileage. The wheels after 288,000 kilometers, and the shafts every 20 to 30,000 kilometers depending on ICE series.
On this ICET, the shafts are going to be checked with ultrasound today. The shafts are comparable to the axles on a car.
To rule out errors during the ultrasonic inspections, the measuring instruments themselves are checked before being used. This is done on test shafts containing various faults.
The check is complete, and I now have to determine whether the specifications, the test faults, all appeared. At first glance, it looks like the inspection ran correctly. All of the faults are there, but I have to check it again precisely in detail.
The detailed check shows that the ultrasound scanner detected all of the faults in the test shaft. The check on the ICE can now begin. The inspector is depot specialist Dieter Knieps. He has fitted an adapter on the shaft and inserts the ultrasonic test probe through it. It moves forward and scans each millimeter of the shaft for hairline cracks, wear, and deformations. The inspector is shown the data from the individual probes on the monitor.
These red lines that you can see here that are shown on the screen are so-called geometric indications. They're caused by the transitions from the sealing ring seat, wheel seat, free seat, brake disc seat, transmission. The blue line here is where my scanner is currently located.
The ultrasonic inspection takes around 20 minutes per shaft or axle.
We'll take a look at the individual probes to see whether any irregularities occurred during the inspection. No findings at all. The inspection is okay. So I can conclude the inspection.
This will be followed by another 20 shafts that Dieter Knieps has to inspect today. In the past, Deutsche Bahn concentrated its ICE traffic primarily on large cities. It neglected the provinces. Deutsche Bahn intends to change this with a major high-speed line construction offensive. Set to cost 10 billion euros, German Unity Transport Project 8 is intended to improve transport links between the east and west and between the north and south. Traveling from Berlin to Munich with the ICE will then only take 4 hours. One of Deutsche Bahn's biggest construction sites in Germany is located in Franconia, between Erlangen and Bamberg. 10 kilometers long, lots of heavy equipment, and 400 workers. In one of the sections, the ICE line's tracks have to cross the regional railway line over bridge structures. More space is also needed due to the 4-track expansion. Widening is only possible on the right because the freeway runs past on the left. Dieter Hilbig, head of construction supervision, is overseeing this gigantic construction site.
Our problem here is this slope, which is at risk of slipping and could endanger the entire railway line. So we had to put in 4 rows of foundation piles, 1 meter 80 diameter, 20 meters deep, into the ground.
The holes for these 300 concrete pipes are drilled by this 180-ton drilling rig. But something on the drive is jammed. Dieter Hilbig, who is under time pressure with his construction site, confers with the technicians. They explain to him that oil has leaked and they assume that one of the sealing rings is defective.
Now we have to see whether the rings are worn. Otherwise, the whole system no longer functions and then we have to repair it.
After several checks with measuring instruments, it becomes clear that the repairs are going to take some time.
So unfortunately we have some minor damage. The mechanical parts are broken. The parts can't be delivered until this evening or tomorrow morning. And we will probably be unable to continue drilling until tomorrow. This puts us under even more pressure because the work has to be completed in 4 weeks. Otherwise the entire construction project is jeopardized.
Another bottleneck on one of Deutsche Bahn's biggest construction sites is Breiten-Güßbach. A new railway station is being built here, and the line through the community has to be widened. A difficult and costly undertaking because houses are located to the right and left of the line. That's why reinforced concrete foundation piles also have to be installed here.
The problem here was the big excavation to extend from the original 2 to 4 tracks. Because the houses are pretty close by to the railway line, we had to change the profile as follows. From the original 2 tracks to 4 tracks in this box section. And we had to vertically install these foundation piles here.
A total of 5,000 of them over a length of 800 meters. Pure assembly line work. The next hole is just being drilled. It has a diameter of 90 centimeters. The drill head eats through the stone and soil. A worm conveyor inside the drilling tube transports the excavated material upwards, where it then drops down on the outside. To protect residents and workers from too much dust, the exterior of the drilling tube is covered. After around 10 minutes, the depth of 8 meters is reached. A pump now transports the concrete into the hole through a hose via the upper end of the drilling tube, which is slowly pulled out during this process. Finished. While the drilling rig is already tackling the next hole, an excavator clears away the waste material from the last hole, which is now filled with concrete. Next, the reinforcement is inserted, a steel mesh cage. It has to be positioned exactly vertically and centrally in the concrete-filled hole with the reinforced side, marked in green, pointing towards the slope.
First, we drilled the holes separated by gaps. When the concrete hardened, these gaps will be closed with additional drilled holes so that we've produced a continuous pile wall, as you can see over there. They are then called overlapping bored pile walls.
In just another 5 months, trains will be running along here. Around 40 kilometers south in the direction of Erlangen, track construction is already in full swing here. 4.5 tons of ballast are required per meter. One of the tracks in this section is almost finished. The sleepers for the second track are just being laid. 1,500 of them have to be placed on the ballast bed each day, spaced 60 centimeters apart from center to center. Each of the pre-stressed concrete sleepers weighs around 200 kilograms.
There are 4 pre-stressing tendons in there that significantly increase the sleeper's flexural strength. The pre-stressing tendons are pre-tensioned to around 50 tons on the right and left of the shuttering. Then the concrete is poured in. And once the concrete has reached a certain strength, the pre-stressing tendons are separated. If these pre-stressing tendons are not inside, the sleeper could break in the center due to the train load here on the outer side where the rail is, and then there's a risk of derailment.
The workers surrounding foreman Thomas Dolitzig are pressed for time and work in 2 shifts. They have to complete 900 meters per day, and they have to work as precisely as possible.
When laying individual sleepers, it's important that they're aligned to make life easier for our colleagues who install the rails later on. If they're not aligned, our colleagues have to adjust each individual sleeper again with crowbars and so on. And to save them having to do this, and to stick to the schedule, the preliminary work has to be completed precisely.
Whenever a few hundred meters of sleepers have been installed, the construction train makes way for the rail layers. They arrive with an excavator that can also run on the track. On one hand, more high-speed lines, and on the other hand, trains that have already been in operation since 1991. It's time for a new ICE, the ICE-4. It's already waiting in the wings and differs from its predecessor in a number of ways.
With the ICE3, 3 cars were always coupled to form a fixed drive unit. That means that only 3 or 4 cars could be added to extend the train. With the ICE4, the individual drive units are bundled in individual cars in an autonomous drive unit, so we can achieve various train lengths very flexibly.
This means that individual cars can additionally be added to the ICE4. The cars are also longer and there are fewer coupling points, meaning more space for passengers.
With this train, we also focused on energy efficiency and aerodynamic design. One example of this is the fairing here on the end cars on the heads. Accordingly, aerodynamically efficient fairings have been fitted there. These lead to a significant reduction in air drag and rolling resistance and help to reduce energy consumption by up to 30%.
The ICE is manufactured by Siemens, but employees from Deutsche Bahn subsidiary DB Systemtechnik are also taking part in today's run. They are to conduct safety tests on behalf of Siemens.
Today we'll be testing a wheel slide protection system that's comparable to the ABS system in a car. To do this, we use soap that's in water tanks. It's applied from the inside outwards. This then forms a slippery film on the rail. We want to see whether the wheels lock up during braking.
The electromagnetic rail brakes are additionally used for emergency braking. The tests can begin. The 2 trained test drivers, Heiner Albert and Ulrich Baum, are sitting in the driver's cab. They apply the brakes at different speeds, sometimes with and sometimes without soap solution in front of the wheels.
We're sitting here in the first multiple unit of the ICE4. It's around 1¼ years old and has been used for test drives for the past 9 months. As you can see, the interior is covered to conduct various tests and to prevent the interior fittings from being destroyed. We also ballast the train with various weights and simulate different weight conditions so that we can really test every scenario.
First scenario, emergency braking. It's due to take place at 170 kilometers per hour and will be triggered in the passenger compartment.
Attention. Clack.
Emergency brake. Emergency brake.
Without soft soap on the rails, the ICE4 takes around 55 seconds to come to a standstill from 170 kilometers per hour. The measuring station is located in a car in the center of the train. The braking data is collected here.
Among other things, you can see the temperatures of the brake discs here. Here you can see the forces of the dynamic brakes, the electric brakes. You can see the rotational speeds of the individual wheel sets here. You can see the brake cylinder pressures here. The relevant signals are then processed. And among other information, the braking distance comes out at the other end.
In this case, it's 1.6 kilometers, a good result. The next brake test is to be conducted with soft soap on the rails at maximum speed, 250 kilometers per hour. Back to line construction for German Unity Transport Project 8. North of Erlangen, rail laying is now set to begin on the high-speed line with an excavator that can also run on the track. The individual rails are 120 meters long and weigh 7 tons. Although they're made of steel, they appear to be as flexible as spaghetti. And now, the other side. A gap of 1 or 2 centimeters is always left between the ends of the rails.
These
These are two rail fish baits that connect the rail joints so that the construction trains can run over them, and the load distribution secures the joint sufficiently so that the rail ends are not bent. The rail is now clamped on one side. On the other side, it remains free so that high and low temperature expansion can take place there within the fish plate, and the rail is still guided.
The workers then secure the fish plate with a nut so that it can't come loose. Now, the bolting machines come into play. First, the nuts are released, and then the sleeper clamps are pushed over the rail base before the nuts are tightened again to a torque of 180 Newton meters.
The bolts are greased. There are two reasons for this. Firstly, for bolting, because the torque is reduced, and secondly, to permanently seal the bolt hole so that no water can get in there and frost or the like can cause the sleeper to break apart.
Some of the sleepers have moved while the rails were being laid. The workers have to use crowbars to space them 60 centimeters apart again. While the tracks are now in place, a number of operations still have to be completed before the ICE can race through here at 230 kilometers per hour.
The rails are now firmly connected to the sleepers, so the track panel is complete. The next operation is to completely ballast the area roughly up to the top of the rail. Then we use a tamping machine that lifts the sleepers and packs ballast beneath them again, so that the end position is reached with a target position of roughly 2 millimeters. Once the rail has reached its final height, the joint here is welded and we have a continuous welded track and the rail can be driven on.
Stringent noise protection regulations have been imposed on Deutsche Bahn for the construction of new and the expansion of existing high-speed lines so that the local residents don't fall out of their beds when the ICE thunders through.
This is a special center wall between what will be the 4 new tracks. These are aluminium elements that are perforated here on the track side with a rock wool in the middle to absorb noise. That means that the walls don't reflect any vehicle noises or wind noises from passing trains. They're self-contained cassettes with a stiff center so that the high wind suction and pressure stresses from the ICE can be absorbed.
The new 15,000 horsepower ICE4 now has to conduct its next brake test between Wolfsburg and Stendal. And it has to do so from the permissible maximum speed of 250 kilometers per hour. The so-called wheel slide protection system, comparable to the anti-lock brake system on a car, is being tested.
To test the wheel slide protection system, we mix water with soft soap and spray it ahead of the drive axles. If this wheel slide protection system doesn't function, the braking distance is longer. Then the wheels lock up and practically scrape along the rail at a standstill. And that causes flat spots in the running surface. So, 2,000 meters, 1,000.
Measurement running, spraying running.
Attention. And go.
Automatic braking.
The wheel slide protection system appears to be functioning. Trained test driver Ulrich Baum, who drove the first ICE1 back in 1991, is satisfied.
The ICE4 has a very innovative brake system in both pneumatic and electrical terms. And you can